हाँ चाय ही दे दो, बिकॉज मेरा अभी 5 बजे से फिर शुरू हो जाएगा दूसरा। हेलो, 1 2 3 4।
हेलो। हाँ सर, आवाज़ आ रही है?
हाँ, तुम्हारी आवाज आ रही है।
जी। अभी ऑप्शन हटा दिया सर, उस समय वेटिंग रूम ऑप्शन इनेबल्ड था।
वेटिंग रूम डाल दिया था क्या?
हाँ हाँ, उस रिमूव्ड है, गॉट इट रिमूव्ड।
ओके। आई एम क्लियरली ऑडिबल?
यस सर।
विजिबल?
यस सर, यस।
टीपी रिव्यू के टाइम कुछ कुछ बंद कर दिया था, तो कुछ कई बार। राजेश, एज पंकज ज्वाइंट।
सर, आई जस्ट कॉल्ड हिम सर, ही जॉइनिंग इन अ मिनट सर।
डीएसपी विल हैव अ चैलेंज टुडे। उनका 2:30 से एक डीआईसी का रिव्यू था।
Yes, sir. Good evening, sir. Pankaj, sir.
Hi, good evening.
Good evening, Pankaj. I'll just join you in 1 minute. I have a small thing to do.
Sure, Sanjay.
Thank you for sharing your time. Huh?
Thanks for the invite.
I've made you, sir, co-host, sir. You
Oh,
want,
okay.
sir, loading up presentation, sir?
Yeah, I'll do that.
Sir.
Yeah, I need to quit and reopen this. Just 1 minute.
Yeah. So you can see your screen, sir. So you're muted, sir.
Oh, okay. Now maybe I'm audible.
Yes,
So
sir.
one I wanted to check, I'll play a video whether that is also audible or not. Maybe
Hello, I'm Watson, your cognitive assistant.
it's there, right? Okay, good. Okay, cool. And I guess yeah, we are all set. So it's 40 minutes, right? Yeah.
How do we structure it normally? It's always, sir, upon you, sir. But normally, what we do is, sir, it's 1 hour structured one, and we try to hand over just by giving opening remarks in a 5 minute or so, and to you, and you can take, sir, up to 5:45 the presentation part,
Okay,
maybe as you want, sir, interactive as you want, and 10 minutes, maybe last 5-10 minutes for the Q&A.
sure.
We tend to wrap it by 6, and we have been able to maintain, sir, this 5 to 6 slot as a kind of a discipline. That's good for our reputation also, so that people also join, though who joining around in that time, sir. So
Yeah,
we
makes sense.
expect more people also to join, sir.
Sure.
Two of our plants, it's coinciding some internal review meeting today.
Okay.
So we might expect some participant to maybe join a bit later if the meeting once finishes.
Okay. Yeah, no
Yeah.
worry.
Nevertheless, sir, we also share the recording of the meeting, so we are recording it. So is that okay, sir?
Yeah, that's fine.
Okay, sir. And maybe sir, I would request you later, sir.
Just for internal distribution,
It
right?
is, sir. It is for internal, sir.
Yeah, then yeah.
So we keep the videos also as an unlisted one in our channel also, not in public.
Okay.
It's primarily for those who have missed this or maybe want to again go through the presentation again.
Sure.
It's a good resource. Daily, we don't get faculties from industry. So
Yeah, I hope everyone, I mean, attendees find it useful. Yeah. So, good.
they're based in Bangalore, sir?
Bangalore. Yeah. How about you? Ranchi, you
Yes,
said.
sir, Ranchi. I recently went to Bangalore for a training program over there.
Oh,
I went after, say, maybe after 15 years, the complete landscape has changed.
India. Yeah.
So I was traveling on Sunday evening,
Uh,
late. In fact, from I left airport at 8. I reached Banerghatta Road at around 11. 3 hours it took me. So
it's a-
there was some at that time some viral maybe on Twitter or somewhere that someone said that it took 14 hours or road trip to cross from one part of Russia to another. And someone shared that in Bangalore में भी यही होता है.
Not that bad, but yeah. It's okay. I guess weather
So
compensates for all the troubles, right? Weather is pretty, I mean,
weather is excellent, sir. Yeah, weather is excellent.
it's like hill station, so that helps.
Weather is awesome over there. It's all the year round like this, or sir, even it's not really cold in November
It's
end
not
of.
very cold. Yeah, it's not very cold. It's pleasant all around except for maybe couple of months where it goes to 35 degrees. Otherwise, it's mostly, yeah, pleasant. Hello, Sanjay sir. Yeah.
Hello. Sorry, we had our monthly communication exercise and वो birthday मनाना था.
अच्छा.
केक कटवा के आ गए.
Okay.
So Sanjay sir, we will wait for a few more minutes, sir.
हाँ हाँ नहीं ठीक है 5 बजे बोला है तो अभी तो 4:57 ही हुआ ना.
हाँ हाँ तो इधर wait कर सकते
People will join at 5.
Okay.
So I had got some, just a moment, I'll check up. मेरे
हैं. Pankaj sir, I would also request you, sir, to give the presentation deck so that we can also upload in our internal portal, sir. If you want
Yeah.
to sanitize it, sir, you can do it. And what is shared?
Yeah. Sure. After the talk. Yeah. Do that.
So we are, meanwhile we start, sir. I will just update you, sir. We have been running this as a part of series Antardrishti, and every month, sir, we do it. So this is the 15th edition. So,
Yeah, please call me Pankaj, by the way. I mean,
Asha.
yeah, that's easy. Yeah.
Sir, I mean, Pankaj, I will try, but it has been ingrained in a part of DNA now when you are in PSU, sir. So,
Yeah, I understand, but we
it
are
was
not
difficult
used to
for me to incorporate when in the initial years when I joined SAIL.
Mhm.
Having worked in corporate for in private for 2 years, 3 years, but now it is again very difficult
Very day.
to move back. But I will try.
So you were saying this program is running for
Yeah,
quite
so
some.
I was saying, Pankaj, that this is the 15th edition of the program. And
Mhm.
we had speakers from, we have given different flavors to our seniors, trying to give to different flavors in area from technology. We had some speakers from technology, some from safety, some from ESG area, decarbonization area, some the soft skills, negotiation, executive presence. So we had different flavors for them.
So, yeah, okay.
And we also, since they all of the seniors are in very got a good
Mhm.
amount of experience, more than 30 years or so in
Oh,
the company, and they are into the key leadership roles. So we try to give the serve it in that manner.
Okay. Yeah, makes.
So we'll wait for a few more minutes, sir. No, maybe a couple of more minutes, sir. Five or six.
Yeah, anytime, whenever
Yeah.
you say, I can get started, right? I'm ready. Yeah, we can wait.
Those who have joined, yeah, may I request to kindly switch on the camera, sir? It will help. I mean, virtual sir, एक group photograph भी हो जाता है. So if you can switch on the cameras. Yeah, I will just change the view so that. So those who have joined, sir, we'll just wait for a couple of more minutes. Just start very short.
रूम से ही कनेक्ट कर
So, Sanjay sir, shall we start, sir? The number has also touched 50, and it's also. Sir, have you go? Okay. So it's muted. You are muted, sir, Sanjay sir.
I think we get started.
Okay.
Let's respect people who have come on time.
Sir. So thank you all, sir, for joining on time, and we'll start the session. So good afternoon, everyone, and we'll start the new session of Antardrishti. And I'll not take much time. I will directly come to the topic. This is the 15th edition of the Antardrishti, and we are excited again to bring a new flavor, a new topic to you, which is the AI in the industrial application. For this, we have Pankaj Dayama sir with us. If I may brief about the sir profile. Pankaj is a senior technical staff member at IBM Research, where he leads AI for Industry Solutions Group. His work focuses on developing advanced techniques for time series analysis tailored to the industrial application. And Pankaj has published over 30 research papers in peer-reviewed international conferences and journals and holds more than 80 patents. Wow. With USPTO. Before joining IBM, he was a research scientist at General Motors R&D India, and he is a master's and PhD in computer science from prestigious Indian Institute of Science, Bangalore. But before we listen to the Pankaj sir, please allow me to call Sanjay Das sir for his opening remarks, sir.
Thank you, Rajesh. And once again, I welcome all the participants for this interaction. We are always conscious of the fact that our senior people are quite busy and they really have to squeeze out time for those interactions. And we respect your time. But we are also quite conscious of the fact that any transformation, any major changes that has to be brought about in this organization, you have to drive it and you have to be aware of what is happening in the world around us. So that you can ask your teams to get into more specifics. And while we have started on all those initiatives which we discussed in various episodes of Antardrishti, this forum is for you to understand the nuances as leaders. What does it take to really get things done? And what is the leadership role in all those things? But at the same time, I also respect the fact that you need people who have been there, done that. They know exactly what they're talking about. And knowing the culture of SAIL, we feel comfortable only when we know a subject in depth. So we tend to ask a lot of pointed questions, which they will say that let my technical people handle it. No, that doesn't happen in SAIL. We will ask the questions ourselves. So we need somebody who understands the leadership context, who understands the big picture, and at the same time understands the micro level details. So that is a challenge for us to find an appropriate speaker for all of you. But I'm sure that we will have a good time and we will fulfill your expectations today also. So on your behalf also, I welcome Pankaj. I was one of his participants in an AMP that I attended at ASCII Hyderabad, and I was impressed by the depth of practical knowledge that he had on certain subjects related to this. And digitalization is a very critical area for us. It's something that we are all involved in and all of us have to work on. And I'm sure he's done a lot of work, especially in the steel sector. And that was the reason I specifically asked him then also that we would like to interact much deeper than what we did there. So thank you once again for acceding to our request, and I'm sure we'll have a great time. So thank you, Rajesh. I think we can get started.
Thank you, Sanjay sir, for setting the context and also welcoming everyone. Sir, Pankaj sir, we welcome you, sir. And without further much ado, the stage is yours, sir.
Thank you very much,
So we're looking
Rajesh.
forward, sir.
Thank you very much, Rajesh. Thank you, Sanjay sir. Yeah, it's a great privilege, and I'm also equally excited to talk to this esteemed audience, right? So I hope you find the technology view of some of the technologies that may be relevant for the industrial sector useful, right? And feel free to interrupt at any point if you have any questions, right? Need not wait till the end. So let me quickly get started. So when we talk about manufacturing 4.0, right, or excellence in operations, it's critical essentially to deliver the main objective is to deliver high quality products. And that's where digital technologies, which earlier were mostly used for POCs and pilots, now they are matured enough and we see a lot of this large scale deployments of this technology, right? And the use of these technologies like AI for artificial intelligence in manufacturing is expected to grow, right, in coming years. So if you look at a very high level, right, the factors, if you look at factory of future, what are the type of decisions where AI, this technology can help, right? You can start with a operational efficiency type of questions. Everyone is interested in having stable product quality. What are there? producing. The energy consumption or some metric or KPIs they may want to reduce. They want to improve production rate. So these are common operational efficiency type of questions where, I mean, the thing is, if you have a lot of data, can technology help? Then there are questions about asset management and performance, like improving asset life, availability of the asset, reducing any breakdowns or stoppages, and how do you aid the maintenance team to identify the root cause and fix some of the issues, right? And then executive visibility questions on how do we get real-time production KPIs, production cost, or demand forecast for different types of products or different types of products that are getting manufactured, right? So these are various questions, and on each of this, the technology definitely, like AI and data-driven approaches, can complement some of the domain knowledge and expertise which is already there, right? So when we talk about industrial AI in the context of industry, the differentiation from typical general AI is that in industrial setting, it's mostly about application of AI, and the data set that we look at in industrial setting tend to be very large. You have a lot of data from sensors. Every second you're collecting so much data, right? But at the same time, the quality of the data, there may be a lot of noise and variability data, very noisy data. There are a lot of issues regarding quality of the data, right? So all those things, when we talk about AI systems for industrial setting, I mean, these are unique challenges that one needs to look at. You cannot just take a general AI model, let's say chatbot for some support system or something else, and similar thing cannot be used for an industrial setting, right? So there is special attention that needs to be paid when we talk about physical operations and systems, right? And building AI models for that. So as I discussed, the brief challenges are like the data is very noisy. A lot of time, I mean, one of the things that makes it very interesting for us is the data is the sensors that you have on various equipment. Let's say you talk about steel blast furnace, there are thousands of sensors. So you have time series data that is coming in, and data is multi-scale, so you have some data at every second, every minute. You are collecting some like samples from labs or quality tests that may be hourly or daily, so they are at different scales. Also, there are a lot of multimodal data, your unstructured data, logs, then if you have uh, images and also time series, so multimodal data is available. And on all these things, domain knowledge, a lot of domain knowledge in documents and other things that is there for a given industrial setting, right? So domain knowledge is very crucial when we want to even build a AI system. How do you infuse this domain knowledge, right? And AI, many a time, some of these decisions needs to be done at the edge. You cannot run everything on the cloud, right? So you need a lot of lightweight models that needs to be deployed, and any wrong prediction or false positives are very costly in industrial setting, right? So you cannot recommend, I mean, approximate or wrong decisions, right? That's incurs huge cost. And what are models? I mean, you have AI models that needs to be used. Many a time there is a requirement for an operator, plant operator who has rich experience on operating the machines. Now, if your AI system is recommending something, so that has to be interpretable, right? Otherwise, it's very difficult to convince them. As a black box, it's very difficult for someone to use the recommendations or output from the AI system, right? So how do you make some of those things interpretable, right?
Pankaj,
Yeah,
can you please go back to the last slide?
yes.
Can you please explain on this a little bit more? AI runs on the edge, not on the cloud. What do you mean by this term edge? Edge
Edge,
means in the plant itself, you want to say?
many a times if you build a model that can be done offline, but when you want to take decisions, right? You want to take real-time decisions on the edge. You cannot pass the data from the sensor, let's say, on the cloud and then do something and get the recommendations back, right? So what are compute is available on the in the plant itself there. If you have the big AI models, ideally the inference, everything you may want to get it done in some cases, right? Many times you may want to do this real time on the edge, right? Instead of sending all the data into the cloud, running something and getting the results, right? So there are use cases where things have to be decided on the edge. So that's so, but that doesn't mean that, okay, there's nothing that happens. Many scenarios where data gets pushed onto your database and it's available on cloud, yeah, you can run inference models and get back the results, right? So it depends.
Good afternoon. This is CGM Electrical RSP. Thanks to Kaushik sir, because that was mined out also. But is it specific to industrial applications? Because AI runs on edge, the statement. Is it for industry specific, or you recommend this to us like that? I don't get it.
No, there are various
That means
applications.
you mean to say that we need not pass on, or we should not pass on some data, real-time data, to the clouds of the suppliers or the providers to get it simulated like that? Is it that you mean to
No,
say?
there are use cases in industrial setting where you may want to do everything on edge instead of passing the data to the cloud and doing it, right? So in real time, you may want to quickly take some decisions, right? But that doesn't imply that there are no use cases or scenarios. When I talk about, let's say, blast furnace scenario, most of those things will be where you pass the data back to the cloud, run something, and come back with the recommendation, right? Or set point recommendation. But there are settings, okay, that needs to be correct. There are settings where you may want to do it on the edge, or there may be settings where things can be done on the cloud. Yeah.
That means basically you are telling that when the speed of the process is fast, it should run on the edge.
Edge.
Where it's not dependent on the speed factor, then we can do it on cloud.
And it can be done on the cloud.
That apart, I think security he's hinting at.
No,
Security may be a second
I guess so.
Second, security also is a second aspect. In many cases, you may not want to push the data onto the cloud. That's also there. And other is real time or speed, right? Or latency that is acceptable for certain decisions, right?
Okay,
Continue.
thank you.
So then, I mean, what are the approaches, right? AI, if you want to deploy at scale, right? So traditional ways of doing things in AI community was, okay, given a problem, you wanted to build a model for address that problem, right? So if you want to, let's say, build a model for asset failure prediction, you take the data for the asset, build something for that. Want to build a model for recommending, I mean, predicting the KPIs for any equipment or process. Let's say for blast furnace, you want to build a model for predicting, let's say, permeability or hot metal time, whatever. So you take all the relevant data, build one model for that specific objective, right? But things have changed, right? How AI is now being developed and used, right? With the foundation model, like everyone would have, I mean, definitely aware of the buzz around large language models, right? ChatGPT and Llama and all those things, right? In language domain. So similarly, there is a parallel trend and effort on building these foundation model, what we call as foundation models, which are using unsupervised data, training some model. So you train it once, and with limited amount of data, the same model can be used for different types of tasks. So you need not have a task-specific separate model done. So we'll briefly talk about this foundation models for sensor data or time series data. Similarly, there are like for large language models which are tailored for industrial settings, because a general model, whatever is there out, may not be able to understand the domain, right? So how do you use, let's say, your process and instrumentation PNID data or failure data or DCS PLC data, infuse all this data and try to fine tune some of the general model for manufacturing domain, right? And how this can be useful for operators. So I have a short demo that I'll show on this specific thing. And third is on vision models, right? On looking at some of the images and data to see product quality and other issues. So I'll not touch upon the third part, but briefly talk about the first two parts, right? What's happening in the community and how that is changing, how these models are much more powerful nowadays and are deployed in production setting in many of the industrial operations, right? Manufacturing operations. So one of the key things when we talk about AI is to understand is that the plants usually experience two variabilities, right? One is yield variability, variability in the yield, and also variability in the quality of the products. And this may be due to various factors. And the idea is if you have some way using the data, using the past data and using AI to predict this variability or downtime, then I guess many things can be done, right, to improve the operations or efficiency in terms of proactive decisions and maintenance actions so that you can So everything finally boils down to, okay, how do you understand this variability and can some of this be predictable, right? If you can predict something in advance, then something can be done to address it. So that's at a nutshell the core of crux of this, right? So before getting into details, maybe depending because audience may be from different backgrounds, I just want to briefly talk about time series, right? So time series is nothing but sequence of points that you get from a sensor. So sequence of points that occur at a fixed periodicity, right? Period of time. So every second, maybe you're getting something from the sensor. And we talk about multivariate because there are like thousands, hundreds of sensors on a given equipment, or so you'll get at the same point data from hundreds of sensors, right? And there is a correlation between them, right? So a value of a sensor in red color may depend on the past values of sensor, not only of red color, but also the blue and yellow ones, right? So there is some cross correlation between the values. So a model needs to learn and understand this, right? So time series analysis basically very core to enterprise operations. There are various applications, but the idea is to analyze the sensor data that can be used to gain insights and then can help in better control decisions, right? So it's not just about predicting what will happen, but it's also about, okay, how can I control the set points? Let's say for equipment, there are some variables that you can set. How can I set it so that my operations enter a much more desirable band or regime, right? So those are some of the things of interest. And in industrial setting, as compared to the regular marketing, sales, other setting is that you have different types of time series variables. As I described, there are like KPIs or target variables, like in sensors, the state of the blast furnace in the context of steel manufacturing, you may have blood, top gas emission, CO2 measured, or you may have hot metal temperature or blast volume or different types of variables. Some of them are represent the state of the equipment, what's happening. Some of them like blast volume or O2 flow rate or some of those things are control variable, which the operator not only knows about the history, but also control during the future. He can control or change the values of those variables, right? So when we talk about modeling, you need to model all these different types of variables in your time series AI model, right? So very quickly talking about what's happening, there are like a lot of buzz around this, as I mentioned, large language model, but last 2 years, 23, 24, there is plethora of time series foundation models that are being developed and that are being used for industrial settings, right? So we'll discuss how these models are getting used, right? So one of the state-of-the-art models over here is Tiny Time Mixer, and that's the one which has been developed by our team at IBM, right? So, why do we need such a model, right? For industry, as I said, traditional machine learning or AI or first principle models, often you train it independently for each process, a separate model. But as I said, the solution now over here is that you train one common model and then use it for different tasks. You can fine tune it in a very lightweight manner for a different task. And that's where this foundation model essentially not only helps improve the accuracy because you have huge amount of data which is not even labeled. So traditional machine learning, you had to rely on labeled data where you know, okay, what is the value of, let's say, failure of equipment. You need to know what time, what failed. You need to know the label to train any, let's say, supervised model. But in this case, the main advantage with foundation model is that because in industrial setting, you have huge amount of historical data where you necessarily need not have the labels. So even in unlabeled data can be used to learn something about your process. And that later on for limited labels, if you have, let's say, started collecting, labeling the data for past 6 months, now with limited amount of labeled data, now you can fine tune the model for specific tasks. So you need not have the labels for the entire history, right? So that makes it very, very powerful. There are, I mean, I'll not get into details of challenges because language models are typically easy to develop. Time series are unique challenges because we are talking about data at different granularity, different sampling rates, and multivariate data. So all these things needs to be addressed. So that's where there is a need for a separate model, and I'll show this TTM how this model is used in various industrial contexts. But just to highlight, this is open sourced. This model is available. Anyone can try this model, and it's huge amount of traction on this with 2 million downloads and a lot of people using it for various scenarios, right? So anyone data scientist who wants to try these models can use it from Hugging Face, right? So how does this work, right? So let's look at energy forecasting, a simple use case to understand what does it mean by a foundation model and how this works, right? So this is a use case of energy demand or energy consumption for a given region, and we have a time series foundation model trained. And this model is used for demand prediction forecast, right? How much would be the energy consumption or demand in future? So the what model takes model is trained on totally different data. It has trained on a lot of time series historical data, huge amount of data. Now we take that trained model, now a new data set, someone wants to use that trained foundation model for time series forecasting. So he can provide the energy consumption values, hourly energy consumption values for past 512 hours, let's say. That's the context. And just feeding that value to the model, he can directly get the forecast, which we call it a zero shot. That means for this energy domain, we are not training the model, just using the past model as is. If he generates the forecast, then he can essentially get the forecast for next 96 hours. This is the light blue color. So it does reasonably well. So the purple one is what is the actual ground truth, and the light blue is what is getting forecasted, right? Using our foundation model, which is trained on other time series data. So it has looked at a lot of patterns, and that model can, if you look at other statistical models which traditionally people have been using, that underperforms significantly in terms of performance.
Which
Uh,
one? Which color is your zero shot TTM?
Zero shot TTM is this TTM
Base. Okay.
base.
Okay.
And then the white one is the statistical model.
Yeah. Okay.
And then we do limited amount of fine tuning where we look at the impact of weather data in this domain, right? Weather may have impact on energy consumption. So we do limited amount of fine tuning, which is very lightweight. And with that, the results of the model also improve, right? So in this domain, because in energy domain, demand domain, a lot of the weather parameters impact the energy consumption. So if we have that data, limited amount of data, as I said, that can be used to fine tune the model, and that helps improve the performance. And that gets reflected in some of the numbers over here, right? In RMSE. So this is a, a simple illustration of how a zero shot
Pankaj ji,
uh, huh.
do you want to say that as with further time, this will absolutely match with the raw data? Because there is a lot of difference even in your zero shot or fine-tuned data. There is a lot of difference between the raw data and this one. So with time, will this be more accurate, you want to say?
No, as you go horizon, right? If you, this is the forecast point, the dotted line. As
Hmm.
you go further in the horizon, the model accuracy drops.
Oh,
Okay. So in fact, you cannot predict, let's say, yeah, next 2, 3 hours, 4 hours, maybe it's easier to predict. But let's say someone asks me to predict tomorrow what will be the demand, right? Further down, so similarly for your blast furnace, next 2, 3 hours, what happens within the furnace if you want to predict, let's say, the permeability or something else, right? One of the, then maybe it's easier. But someone says, okay, tell me next 8 hours, after 8 hours, what will happen? So the accuracy definitely drops down as you go further into the future. But what can help us bridge this gap, what are you seeing here, is if we have some domain expertise, right? Or some features from the domain saying, okay, this is what influence, and that data is available, then that can be used by the model to learn the relationship and plug those gaps. That's where I'm saying that data-driven approach with domain expertise is the sweet spot that will help. Now, if you look at asset domain, right, asset specific times. If the earlier example was energy forecasting, now let's say you look at an asset like a chiller, right? Industrial chiller where you have a lot of data and you want to, let's say, some target column you want to predict, right? Condenser water flow. based on various other variables that are available. And you have context length of, let's say, 96. That means last 24 hours data is available. Then based on that, you fine tune the TTM for this asset specific data and get the predictions. And you also can generate conformal prediction in the sense that what's the range, right? Band around which the prediction can lie. And based on that, you can essentially, this can be used to say, okay, if there is the operations will be within the normal band, or if something will go out of the normal acceptable band, right, in the near future. And based on that, some actions can be taken. So this is again a simple example just to illustrate how these models can be used. Now, what does this mean for industrial operations, right? So as I said, industrial operations, there is multivariate relationships, and many a times the general time series foundation model, which is pre-trained, it may be difficult to use it as is because you have a lot of complex relationship between these variables, right? So that's where there is a need for domain specific. Let's say for an industrial domain, cement domain, maybe you want to build a separate foundation model for all the things within a cement. Or steel domain, maybe you want to build a separate model, right? So industrial domain, because these variables, each of these variables, there's a huge amount of cross-channel dependency, which is very different across different types of sensors are there, and the relationship is different. Maybe a domain-specific model makes much more sense for industrial scenario, right? So you have extensive pool of sensor data that's there in different industries. And the idea is we have ways of training and building this base foundation models. And once you have this model, they can be fine-tuned for different types of tasks. Let's say the same model can be used if you want to do anomaly detection task, right? Or you want to, let's say you want to detect, different types of anomalies within equipment. Or you want to use the model for failure prediction. So take a limited amount of failure prediction label data, fine-tune this model and use it for that task. Or health score for a asset, right? So different types of tasks, the same base model can be fine-tuned to use for different types of downstream, and that gives us huge amount of benefit, right? So a fine-tuned model essentially can be used for tasks that will provide you different types of insights. So you start with unlabeled sensor data because key benefit is huge amount of unlabeled data is used for pre-training the model. Fine-tuning can be done on limited amount of data, so that gives huge benefit. So underlying what's happening, right? How we are able to do this is if you look at these models, they have certain something called as encoder decoder architectures. So I'll not get into too much detail, but you take the input sensor data, it learns to map it into something called as compressed representations. And these representations, one intuitive way would be by color, maybe this corresponds to different regimes of operations, right, of certain equipment. And then once you have the representation, there's a decoder which learns how to reconstruct this. So you have an input data, you are learning some representation, and you have a decoder that is able to reconstruct the original data. So in this original data, you are trying to reconstruct, but you are learning in the process a compressed representation. So here you don't need any label data. You take whatever sensor data is there, try to reconstruct the same data, and in the process, you learn some representation. And this representation can be used for now different types of tasks, right? So you can use it for failure or anomaly or different types of tasks where you now plug in a different head and try to build the model, right? So that's at a high level the approach that is traditionally used, right? Now, this is one important point I wanted to cover in today's discussion. So, foundation model is one story, right, where you know what will happen in our equipment. But I guess the core thing for operations is like how do you prescribe something? It's not just about predicting, but many a times you have a lot of this control set point variables, right? So, how do you recommend, okay, my equipment next 2 to 3 hours, this is how you should set certain important control variables, right? Values of the control variable so that you have certain objective in mind. Let's say you want to maximize the production rate or maybe minimize the raw material consumption, and you have a lot of set of constraints, right? Maybe you want to maintain the equipment uh, operations within, let's say, hot metal temperature within certain range of, let's say, 1400 to something, right? Or top gas CO, CO2 you may, or ETA CO you may want to maintain within certain bounds. So these are your constraints. In future, next 6 hours, I want to maintain these things within a range. But I want to model to recommend me the set points, the ATs are your set points values, such that my objective is optimized, right, or maximized. So how do you do this, and where does foundation model fit in is that these constraints, because in future you want to know, okay, if I change this set points, AT value, what will happen to my hot metal temperature? This prediction will come from something called as a model, right? Time series model, because they will know, okay, if this is my set point, as I discussed, there are different types of variables. The model can take, okay, in future, if this is my set point for different thing, what will happen to my state of the furnace? And these are fed in as a constraint in the optimization. So these two should work in tandem, right, for you to come up with a set point recommendation. And this is where there are like very unique and novel way in which we are able to plug in this foundation models into the optimization framework. Otherwise, in general, these are highly nonlinear, huge models, and you cannot fit it into optimization and get a optimal solution, right? Because it's not convex or, and there are very novel ways in which, I mean, this can be translated into set of piecewise linear constraints through surrogate models. And that's what gets used to come up with prescription, right? So let's look at example in blast furnace, right? So blast furnace, as we say, it's very dynamic, very, very complex equipment, and a lot of first principle simulation based models to enhance the operations. And the key question is, can we have some intuitive way of being able to do what if analysis? What if I change something in the furnace? What will happen to the state of the furnace, right? So as I said, high dimensionality, hundreds of sensors, uncertainty in terms of randomness in raw material, environmental conditions, data irregularities, some data is available uh, periodically, some of them maybe you do it sampling at a very infrequent rate, and the dynamics within the furnace is highly nonlinear, right? So that's where, I mean, when we talk about the approach for using this, so you have a lot of this sensor data outputs from first principle model. So once you abstract the data, these are the models that are built using the time series. We train a time series foundation model, base model, and use it for different types of tasks, like predicting different KPIs of interest, like permeability, hot metal temperature, few other KPIs, which ideally you may want to maintain furnace, very stability of the furnace, and a lot of other constraints are there. So all those things are trained using the time series data, the fine-tuned using the time series foundation model. And that is fed into a optimization engine where you want to, let's say, recommend the coke rate, PCI rate, or oxygen flow rate. These are different set points that you want to recommend in such a way that your objective is maximized. That can be in terms of production rate or uh, maybe the input consumption, right? Raw material consumption. There's different types of plant specific constraints that you want to meet, right? So this is at a high level a closed loop system, how things work with in tandem with the foundation model and the optimization engine, right? So more details on how this gets translated into set of constraints, but anyone who is more interested, we can share some papers and have a more deep dive into how these things actually get translated into optimization, this thing, right, setup. Any questions on this before? Because I'm not sure whether I'm moving because I just have 10 more minutes, so I want to cover one more aspect. So I thought,
Yes, I have a question. I'm
yes,
CGM instrumentation and automation is CPAT.
yeah.
So how it is different from level 2? Because the blast furnace model, whatever you have shown, so the same parameters or same predictions are available from level 2 also. Of course, there we have fixed mathematical models, but the same thing you are deriving from your AI optimization. So how you can differentiate between the level 2 presently running and the BF optimization process brain, whatever you have explained.
So here you are predicting in advance, next 4 to 6 hours, what will happen, right? next 4 to 6 hours, you are saying, given the current observation, last 12 hours, whatever I'm observing, different things, can I tell in next 6 hours what will happen, right? Ahead of time.
So let
And
us say I have level 2 already in my blast furnace, and I am going to implement another sort of things, whatever you are proposing. So with these two advice coming from level 2 and this optimization, so where I am going to lead to, which one I'll take into consideration?
so that is where the evaluation, right, of this model performance, right? So what are these recommendations will recommend, I mean, this will come up with recommendations of set points in such a way that your operations are within the desirable band, right? Whatever you want. And so based on that, you will get certain production rate or something. Similarly, I guess your level to the existing system, there may be some outputs that are provided, right? So one has to do hot trials and then see, I mean, how these models perform, right? As compared to the existing incumbent approaches.
Yeah,
But
how to use these recommendations actually. Suppose you say actually I have got a level 2 system as Patra Sahib has already mentioned, and with this model running and some recommendations coming, how to use that? It is a discretion of the operator, or it can be integrated to the level 2 take corrective action, or it is purely it is advice and we may use or may not use like that.
so right now it's not a closed loop automated system. So right now maybe you have a dashboard where this goes to the operator saying, okay, this is what it's recommending, right? Now it's up to the operator. It's more of a decision support for the operator, right? So it's up to his discretion saying that, okay, this is what it is supporting, suggesting, and why it is suggesting, because you'll also get the predictions for these, right? Different KPIs. Let's say it's suggesting increase the blast volume and reduce the PCI or something. And based on that, it's also telling that, okay, if you do that, then maybe the permeability will go in certain direction, and these forecasts for next 6 hours.
There
Now
are
it's
two
up to
things.
the expert.
There are two things. You are getting data from our system and predicting. Can I play around the data myself and see the outcome in this model? Is it possible that I manipulate the data, input data, and see the outcome just like a digital twinning system? Is it possible in this model?
Yeah, you can feed whatever input you want, right? So if you have, I can pull it from your system, or you can play around with the data, but data has to be from realistic distribution, right? It cannot be a time series which is very unrealistic, right? Which is not seen in the history, right?
Right.
Like you cannot have a data where you say
Ah,
hot metal temperature jumping
right.
every month, right? So if it's realistic distribution, then you can cook up scenarios and test out the model, right? In a very controlled environment. That is very much possible. If the model has seen historically those distributions, it will learn those patterns. But the cooked up data has to be realistic. That's all. But I mean, definitely, I mean, that can be, I mean, it's just about providing the inputs. Either the input comes from your system directly, or you, yeah, create something, right?
Right.
Pankaj ji,
Yes.
have you tested this in any blast furnace? Because you're talking about blast furnace. Has it been tested in any of the blast furnaces?
Yeah, these models have been tried in, yeah, couple of engagements. But yeah, with different clients, right, for IBM.
Big furnaces?
Big furnaces, yeah. So okay, how much time? I just want to cover one more aspect. So I have 10 minutes. So this is again similar thing we have done for Cemex, right? Cement industry, right? Cement mills. So a lot of couple of projects on again autonomous operation and recommendation for cement industry. But I'll not get in. Instead of this, I'll talk about one more important aspect is about this virtual operator assistant, right? And how this also can be useful for plant operations. So before getting into the technology, let me quickly show a demo, right? 2 minutes demo.
Hello. I'm Watson, your cognitive assistant.
Is it
How can I
audible?
help you?
Audible to everyone?
Yes, it's audible.
Yes, yes.
Watson, show incidents from February 2022.
Here are 1,000 results.
Show incidents about liquid nitrogen flow.
Here are 1,000 results.
Show incidents like this.
Here are 1,000 results.
Aggregate this field.
Okay. Here are 25 results.
So that shows that this sensor has a lot of problems, but I don't actually care about Elmsford. Show incidents like this.
Here are 2 results.
Okay, so out of all the ones in Poughkeepsie that are about liquid nitrogen, this is the worst offender. So now let's look into what's going on with this particular sensor. Watson, plot process variable for this sensor for February 2022.
Here you go.
Remove all aggregation.
Okay, I'll remove any existing restrictions. Okay. Here are 42 results.
Watson, display the control network for this sensor.
Tag 3PD866 belongs to 2 control networks.
All right, so let's see if we can just unscramble this a little bit. And we see that this is the sensor of interest is feeding into the 2 control networks. It is not being written to itself. So this view is not really going to tell us what ails this particular sensor. We have to try something else. Display the process diagram for this sensor.
Okay.
Watson, display tags most correlated with this.
Okay.
Watson, plot process variable for these sensors for February 2022.
Sure.
Watson, in detail, show.
Okay, so I guess the key thing over here is right now, if we want, so virtual operator assistant is essentially way where you have multiple data sources and the operator is trying to monitor this system. So how he can interact to speech, text, pointing to different information, right? And traditionally, there are like different tools for each of these, but and that takes several hours to come up with the root cause. Whereas in this case, everything gets integrated through knowledge graph and large language models, right, for the specific domain, so that I mean, yeah, you can have this assistant available to the operator. It's tooltip, right? So it accelerates learning and reduces the time and increases the efficiency, right, of how root cause can be analyzed, right? So again, I mean, the way it is done is you have this large language model that directly cannot be used. So we have this lot of domain knowledge through all the sensor data that gets infused to you content ground the LLMs for a specific domain, and that is then used appropriately with through different RAG patterns and knowledge infused prompting to support operators in various decisions, right? So that's at a high level. More details again. If anyone in the team is interested in knowing more about this technology and playing with it, then yeah, I'll be happy to, I mean, yeah, discuss in a smaller team, right? Yeah. So any questions on this part?
Any questions from the participants?
Sure. So I guess, yeah, that's at a high level I wanted to cover in 45-50 minutes and more.
Pankaj, are
Yeah.
you willing to do a POC in any on one of our furnaces?
Yeah, I mean, we'll have to engage the right, I mean, yeah, client-facing team, but as a research, definitely we support and yeah, do POCs with clients, right? Yeah, so yeah, we can discuss this right offline. But in this domain, we are interested. Regression optimization and time series domain, definitely we are interested and working
Why
with.
I am asking you, you know that I don't know whether you have this knowledge or not. SAIL is going for a large scale digital project, digital transformation project,
Okay.
where we are hiring a consultant who will be dealing with these type of things. So I don't know whether anyone has contacted you or not on this.
Actually, no one has. I'm not sure from IBM who is in touch for this, right? So I'll maybe.
No, just wanted to know because we'll be doing such projects. In
Oh,
that
okay.
digital transformation project, we'll be doing or working on this because it's basically on analytics, AI, all these factors.
Sure. Yeah. So I will be more than interested to participate, right? And then see. How.
You have given your contacts, no? That means if we want to contact you, we can.
With the permission, Banga sir, can I share with the group?
Yeah, you can share. Please go ahead.
I will, sir, share.
Okay, Rajesh.
Sir, I will share.
The contact detail is in the slide deck itself. Very beginning.
Yes. Sir, apart from you have given some use cases for the blast furnaces. Sir, apart from that, sir, which other areas, sir, this has been deployed, sir?
So various industry, food processing industry, cement industry, and then in general for energy and utility sector, right? So there are various domains in which, I mean, the technology. So research, as research, we have developed this and shown that this works. Now the consulting, IBM consulting is taking to various clients and using this technology and delivering projects, right? So that's the most scalable approach for us. But initial proof points, yeah, we have worked in steel, cement, and food processing industries, right? And industrial sector.
So in steel, sir, it is primarily, sir, blast furnace.
This is blast furnace, yeah.
Sir, we are also open to the question and answers, sir. Any other participants that we can take this as an opportunity to interact directly with Pankaj. If you want, you can also use chat box. Wait for a couple of minutes, sir. If anyone wants to drop, I think, sir, they during the session also there were a good amount of questions.
A
So
lot of questions, yeah.
yeah.
I hope folks got something out of this, and then more details, yeah. There are articles, research papers published, and conferences, everything. I mean, if required, I can share.
Okay.
Yeah.
So any more questions? Is there or we will?
Good evening. Yeah, actually, this was mainly focused at manufacturing, say transformation in manufacturing. Pankaj ji, we have any such models which can be of aid in marketing or our services area also?
So this forecasting, right, and marketing and demand prediction and everything, right? So people are in retail domain also, right? These models, TT, whatever we call it, a tiny time mixer, the foundation models are used in other domains as well. Today, the focus, whatever I discussed was specific to industrial sector,
Mm-hmm.
manufacturing, but these models have been used in other domains as well. So if you want to do demand forecasting, sales or inventory management or what, right? So or effectiveness of different marketing, predicting, okay, if you invest, what will be the effectiveness of different marketing strategies or something, right? So
Yes, yes.
anything where you have time series data,
Hmm.
on top of that, you want to do optimization as well, like optimally design your incentives or strategies, right? Or budget allocation. So those problems, I guess, these models and techniques.
इसको phone कर लो, ब्रजेश
So
को।
this pre-trained model
ब्रजेश
has been pre-trained on publicly
को
available
बोल दो
data, which is from different domains. Retail, energy, stock, and various time series data, right? The pre-trained time series foundation model, as I discussed. So this has been used in various sectors and domains.
Thank you, sir. Thank you, sir.
Since our C and IT people can take cognizance of this input, and we will try to use it here for that.
We will
And it's
sir.
really, I mean, if you have some folks who are experienced with, definitely you will have folks with, I mean, yeah, basically data scientists in the team, they can directly use it from Hugging Face. We have example notebooks given there where they can directly take the code, plug in your data and try it out, right? The first cut. We have open source a lot of things.
Oh,
And few
great,
things
sir.
are still within, right? The secret, some other secret sauce are still there. But for the first cut, whatever you want to try, definitely can be tried with the open source model to see how it works, right? Yeah.
Great, sir. That's again another great sharing, sir. Sir, we wanted this to continue, and but again, considering as sir also mentioned, we wanted to maintain the discipline of the time also, respecting our seniors. They have joined in time and the series part. So thank you, Pankaj sir. Thank you for the enlightening session. But I would also request now Sanjay Dhar, sir, to again, learning and application is one part, what you shared, sir. So I would request Sanjay Dhar, sir, to kindly give us some proceeding summary, sir, and we can also get it from the steel industry. That will also help us.
Thank you, Rajesh, and thank you, Pankaj, for sharing your insights. The basic reason of getting into a high-tech area, but still, bombarding my senior people with these aspects was that we will be dealing with these kinds of projects, and you will be asking a lot of questions as the end users. And we wanted to understand what are the broad approaches that people take. And this is the jargon that the consultants will throw at us. So we also need to be clear about what they are talking about. And
Yeah, that's where I guess one important thing we have done is we have open source some base version. So I mean, instead of looking at jargon, maybe team can try it out and then see if the initial thing is promising, then I guess it's worth taking it forward.
If you can share the link, I will share to the people, sir.
I'll share it with you, Rajesh.
Please, sir.
So this also demystifies a lot of things because we don't treat it as a pure tech issue. It's also an issue of what is our business case and how do we really apply it. And also figure out how is our basic problem more generalizable. So you gave us a very interesting input on using foundational models, which essentially don't need a lot of labeled data. We have a problem in challenge in sale. We have a lot of data, but we don't have a lot of labeled data.
Exactly. Yeah.
So I think you've given us one good way. If somebody will keep asking us for more labeled data, we can always tell him that, okay, there's another way. We have the data, but you figure it out. And you've identified for us some use case applications in terms of how it can be done. You also helped us to understand the opportunities of combining the foundational models with that derive on a data-driven approach to domain knowledge and getting much more reliable models. I think that's also very important for us to really appreciate. Which means, and we have a large amount of data and we have domain knowledge. It's just that we don't have a lot of labeled data.
Yeah.
So I'm sure it will work quite a lot. You also have to clarify a lot of issues about how it is related to our level 2 automation and things like that. We got queues. There are queues we can work on. You've given us some insights on how we can try out these models in an open source and figure out what it is really like. I'm sure it'll be very useful, and thank you once again for these insights. And we also look forward to meeting our CGMs and EDs with another episode of Andhra Maybe next time we'll keep it lighter and do something behavioral. So wish you all the best. Thank you once again.
Thank you, Sanjay, sir.
Thank
you, Pankaj sir. And as sir, you mentioned one line, sir. Before closing out, I'll just repeat it, sir. And it will be in continuation what Sanjay sir said, that data-driven approach along with the domain expert is the sweet spot, sir. And we will be looking forward to this, sir, because as sir has also mentioned, that data-driven managerial decision is a way forward, sir. You have showed us a way of doing it, sir, Pankaj sir. and you have also showed us the resource also. You have told it, sir, in terms of the open source. So we will be certainly, sir, we'll be coming back to you, sir, for more such engagements, maybe for a focus group also, sir. And really, sir, Pankaj sir, we are thankful to you for sparing the time and with your busy schedule, sir.
It's my pleasure. Thank you once again, everyone. Thank you for your time and paying attention.
Thank you. And
Thank
thank you all the seniors and all the participants to joining over here, sir. Thank you, sir. Thank you, sir. Thank you, everyone.
हाँ जितेंद्र बोलो। अच्छा ठीक, अच्छा।